Stars, actually right off the bat, you guys had one of the hardest questions here. I'm like, are you serious? So it was a difficult one because you had a couple of the hard ones. Okay, the best answer is A. Circumpolar stars are the ones that make a bullseye. So the best answer is that they're always above your horizon. B's not right. Circumpolar stars are usually close to the North Star, but they don't have to be because, for instance, if you're at the North Pole, all stars are circumpolar. So I know that was a tough one. Ugh, that's very hard. So A is the best answer. The second one, suppose you lived on the moon, which would be true, and C would be true. Your weight would be less due to the gravity. It's 1/6 gravity of the moon, but your mass would be the same. 3 was another one so many people missed, and I was like, oh, what's wrong with 3? And I'm like, oh, yeah, 3, I can see why. You guys are right on track. You guys said 1 second will be going 10 meters per second, 2 seconds will be going 20, 3 seconds will be going 30. And the catch here is what are the units? So the units actually would be meters per second. So C is the best answer for 3. If you missed that, you're in great company. Now, when I'm looking at questions to snag for your final, I'm not going to snag questions like that. I'm like, I don't like putting those. I'll try to put the ones that I'm like, 5 years from now, they know the answer to that one. So I will, for your final exam, in May, I'll be here before we know it, I'm going to pick some of these questions up and put them on a separate test. So you'll see some of these questions again. The next one, NCP stands for the North Celestial Pole, which is Polaris right now. And the best answer there is B, that if you know the altitude, okay, then you know your latitude. So question 5, actually question 5 I got wrong. I hate it when that happens. So I had to go ahead and hand check 5 on everybody's thingy, okay? So you guys, most people got this right. 5, the order of the phases of the moon, the best answer there is D. It goes noon, then it's waxing. We have waxing crescent, it's C, final answer. I went and hand checked everybody's, the answer is C. So on the answer key out there it says D, so make sure we're all on the same page. The right answer is C. What's wrong with D?
It doesn't do, it has to go first quarter before it goes to the last quarter.
Exactly. The thing that's wrong with D is actually these two are switched around. And I got in a hurry through my answer key. So C is the right answer there. It goes new, waxing crescent, first quarter, waxing gibbous, full, and then it starts to wane. Waning gibbous, third quarter, waning crescent. Back to new again. Number 6, the force due to gravity actually will decrease as the distance increases. So B is the best answer for 6. 7, we experience nighttime when C, the side of the Earth you occupy is facing away from the sun. 8, Galileo helped the whole kind of get past the heavens are perfect thing by B, observing blemishes on the sun and the moon. So B is the best answer there. Question number 9. Go down to 9. Looks like this. When the planets are farther from the sun, they move slower than when they are near the sun. They appear. What's the question there? Okay, there it is. 9. What causes that retrograde or backward motion? And the best answer there is B. That Earth passes another planet, and the outer slower moving planet appears to move backward. So B is the best answer for that one. Question 10, as planets orbit the sun, their direction of motion is continually changing. That's a type of acceleration. And then actually, according to Newton's second law, force is equal to mass times acceleration. Since there is acceleration, there must be some force acting upon it. So the best answer for 10, what I was after, was D. Question 11 was this sort of thing, where you extend your arm. And I was after the width of your fist. That's about C, 10 degrees. Question 12, if you have, you've taken a picture of the galaxy and you look at something that's 1 billion light years away, That actually is a snapshot of the way it looked 1 billion years ago. And this was related to a short answer question that you guys answered. And it's because that light took a certain amount of time to get to us. Question 13, C actually puts it from smallest to kind of largest. So there's you, the Earth, your solar system, the Milky Way galaxy, local group, and local supercluster of galaxies, and then the universe. So this is where, and I'd like to say this won't happen again. This is where actually I inserted 2 number 13s. Why did I pick 13? I don't know. I didn't pick it. It just was an accident. So on my answer key, if you were taking it in this room, I told you to take 13, put a thing through it, and make it number 29. Okay? Now, if you were taking this test elsewhere, I kind of caught you what you did, I hope. Okay? So if you renumbered them, that worked out fine. I kind of follow what you did. So anyway, if you go down to 29, the answer to 29 is A, actually. The reason that the same side of the moon is always facing the Earth is because of that synchronous rotation. That's described in A. It takes the same time for the moon to spin on its axis one time as to orbit the Earth. Question 14 then, back to 14 from 13. The tides on the Earth are example of gravity in action. So D is the best answer there. Question 15, which of these is not a fact associated with why the Earth has seasons? And they are all true except for E. It's not true that we have seasons because the distance between the Earth and the sun varies. That's not true. Question 17, why did Ptolemy have those epicenters? And he had those to explain why the planets went backwards, retrograde rotation. Down to 17. 17. Why is it summer in the northern hemisphere when it's winter in the southern hemisphere? The best answer there is D. The northern hemisphere is tilted at that time toward the sun and receives more direct sunlight. Question 18. Can we make those star trail photos? That's because A, the Earth is spinning on its axis. Question 19. Which of these is true about the motion of the stars? It's true that C, throughout the course of the night, they will appear to move counterclockwise around Polaris. A, B, and D and E are not true about the motion of stars. Question 20, what makes the Polaris so important, so special, is right now it's very near where our north axis of rotation is pointing. That makes it our north celestial pole. Question 21, C, Galileo discovered that there are moons orbiting the planet Jupiter, and we'll be talking more about those moons, that are all in synchronous rotation. I looked it up with their planet. Question 22, the light year is equal to, the best answer there is D, the distance on that light travels in 1 year. Question 23, which lunar phase, and 23 might have been another one that on your review sheet I didn't quite hit you over the head with. But in Chapter 4 we talked about tides. And there's 2 special tides. There's the spring tide and there's the neap tide. The neap tide actually is what this is talking about. When the tides are least pronounced, and that happens when the sun is at a right angle to the moon. So that happens on your quarters, first and third quarter. So E is the best answer for 23. 24. And 24, you probably will see on your final, because I want everybody to know this.
I don't know why.
Regardless of mass and aerodynamics and all that, if we didn't have air here, kind of like on the moon or in a vacuum, you drop 2 objects and they will accelerate at the same speed. So they'll hit the ground at the same speed. So the best answer is C, that the golf ball and the bowling ball will hit the ground at the same time. Question 25, which is true about the moon? D is true. That we do have this perigee apogee, so the distance varies as the moon orbits the Earth. Question 26, Kepler, his first law, talked about the orbits of the planets were in shapes of ellipses. Question 27, Polaris has not always been our North Star. There's this thing called precession, the 26,000-year thing, and we have had a different pole star. So that actually is kind of summarized in A. Question 28. Question 28, Kepler's second law, which states that as a planet moves around the orbit, it will go fastest at perihelion and slowest at aphelion, okay, is actually the equal areas sort of thing, and that A means that it travels fastest when it's near the sun and slowest when it's away from the sun. So A is the best answer there. So those were each worth 1 point apiece. And then these were each worth 2 points apiece, and it's possible to get 1 out of 2 points here. Okay? So I wanted you to tell me the 2 stars that we used to find the North Star, Polaris, and they are the bull stars in the Big Dipper. That's what I was after, the farthest bull stars in the Big Dipper. Again, question 30. Good job. You got AU, astronomical unit. Sometimes just close your mind and just write something down. Okay, is the average distance between the Earth and the Sun. I was after Orion. It's beautiful this time of year. You can see the belt stars and the sword kind of hanging down from it. For 32, I was after ecliptic or plane of the ecliptic. I got some interesting spellings for some of these, as marking out the path that the Earth orbits the Sun in. 33, celestial sphere is in that model that has kind of it's a hollow with the Earth in the middle and has the stars embedded on it. That's celestial sphere. Kinetic motion. I guess it's kinetic energy. Well, I don't know. Somebody must have made a touchdown there or something. So that should be energy. I'll put E for energy. Kinetic energy is the energy associated with motion. 53, precession is where the Earth's axis of rotation is kind of coning. I think somebody put wobble out there, and I gave you a 1 out of 2. So feel free to kind of just try to come up with some things when you're faced with these questions. 36, if you put nebula, I gave you 1 out of 2 there because I was like, that's pretty awesome. But the whole idea of a nebula coming from a star that blew up and forming no more stars, that's actually called galactic recycling.
That was the one term I couldn't find in my book.
You couldn't find in your book?
No, I wrote it. It took me
Oh.
a minute. I almost put celestial recycling. I'm like, wait a minute, it doesn't.
The near side of the moon was what I was after for 37. We have the near side and the far side. Yep. 38 was parallax, as basically the observer changes location, and then that object they're looking at changes its location against the background. Okay, that was the whole wink and an eye thing. Okay, result of parallax, a nearby object, that's your finger, will change its relative position relative to the background as your observer changes its location. That's why you choose different eyes to open and close. 39, hypothesis, is that kind of initial best guess after you have observation, testing. You come up with a hypothesis, and it stays a hypothesis for a long time, remember. I did, you guys have some of the best questions. Somebody asked, can we take a hypothesis and elevate it to a law? And I looked that up, and there's a somewhat, I think, almost of a subtle difference between, I meant theory. Can we take a theory and elevate it to a law? And there's a difference between those two. So kind of no, but kind of yes. So these were mostly worth 3 points apiece. 41 was worth 6 points. So for the first one, I was after those 4 dates. And in some cases, you didn't have to tell me which was which. Okay, the solstices are in December and June, 21st, 23rd, 2 through 23rd. The equinoxes are in March and September. For the next one with 6 points, I needed to be able to kind of see how you were, I needed to be able to understand your diagrams. Of course, we have a solar eclipse potentially at new moon, right here, that's the first one. And we have a lunar eclipse potentially at full moon, over here. 42, that was a homework question, I think. What do we mean when we say that the farther away we look in distance, we're actually looking back in time? It's because that light takes a certain amount of time to get to us. I liked what I read because to me that's an important concept, kind of a mind-boggling, awesome concept of looking at faraway objects. So number 43, oh, did I miss? Are you serious? Okay, so I didn't have Galileo over here. I know. So number 5 is Galileo. So I was looking for 2 things for you to put them in order. So I'm going to put 5 Galileo. And to get full credit, you had to actually say something about them. I'm just going to say use telescope for stars. And it was pointed out to me, and I kind of remember this before, when I talked about the intersection between Copernicus and Brahe, I think on the board I said that Brahe actually was brought on board by Copernicus. And there was like 3 years difference between the death of Copernicus and I think the birth of Brahe. So that intersection did not occur. He took his ideas, but they didn't work. They did not work together. Okay, so yeah, it was like, and one other time I was like, wait, that can't happen because they're like, he's dead and he's not alive yet. So, but I was looking for the order and a little bit what they did. Okay, now this one could make it to the final. Who knows? 44, I would take a couple different types of answers, but I was after something about the Milky Way. I love the Milky Way. It's beautiful. Okay, the darker the sky is, the more like you already see it. And you were looking into the disk of our galaxy, and some of you guys said the galaxy's flat. That was cool. And some of you said kind of one of the things I wanted was that the reason it looks like wispy is because they're like way far away stars. I think that is so cool. So there's a couple different ways to do that. And then continuing on to the bottom. Oh, yeah. So 45 was, I wanted you to pick your favorite of Kepler's laws. Some of you guys did all 3, which is fine, but you only had to do at least one and explain it. Yep, that's okay. Pick one, state one of Kepler's 3 laws. That's great. And then down here, the extra credit point, I actually saw this on a test bank. So here we are. This is a lunar, this is a, this is lunar eclipse. The moon, this goes over here, that's my moon. It's a full moon, okay? But actually it's passing through the Earth's shadow. And a lot of you totally got this right. Basically, you would see this disk of the sun, and then the disk of the Earth would go in front of the sun. So some of you said you would, at the totality, you would just kind of see maybe the Earth with like a sun ring around it. That is so cool. Some of you said that it would go black, and to me, I kind of thought, well, that makes sense. Okay, the Earth is blocking out the sun at that point because you're on the moon. Okay, so anyway, that's how that works. So there's your first